Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today's lecture, I will be talking about firstly building energy management system. Then I will talk about building energy simulations and how this simulation is used in MS1525 and how simulation is used in GBI. To begin with, we should familiarize ourselves with building automation system or BAS. It consists of computer management system of first building energy management systems, physical security and access control, fire and life safety issues, and other systems such as elevators, public announcements, and closed circuit television. So that's the items that is covered under the umbrella of building automation system. Let's focus on the building energy management system. Okay. Building energy management systems are computer-based control systems that control and monitor a building's mechanical and electrical equipment such as heating, ventilation, lighting, power systems, etc. etc. They connect the building services plant back to a central computer to allow control of on and off times, temperatures, humidity, etc. In the past, they used cables to connect the plant to a central supervisory computer where building operators can control the building. But nowadays, we know that we can use Wi-Fi, various wireless Bluetooth communication mode to transfer data between all the components of building energy management systems. Okay, and it requires a software to provide control and functions to monitor. To set alarms and allows the operators to optimize building performance. So this is still very generic. Nowadays there are a lot of building energy management system you can choose from. In MS1525 in clause 9, energy management system, specifically on the control system, is being mentioned in clause 9 under the heading of energy management control system, and subclause 9.1. The energy management system is a subset of the building automation system function. It should be considered for buildings with air-conditioned space of more than 4,000 square meters. The EMS is a state-of-the-art system and is microprocessor based. Generally, the EMS has three main functions: to control the equipments. When we say equipments, in this case, all the equipments that is needed to operate a building, the air conditioning controls, the chiller control, lighting systems, all the other various services in a building. Okay, so those equipments can be controlled provided they are linked to the EMS. And another important aspect of EMS, it allows the operators or the owner to monitor the equipment, the performance of the equipment. They can check whether a particular lift is functioning or not. They would know where is the problem when people report, for example, the building is hot in certain areas. They can check whether chiller 1 or chiller 3 is performing or not. So with this system, they can immediately identify where the problem is. And you can integrate a lot of subsystems. For example, sensors. When you install sensors in rooms, and you can link it with lighting operations. When the sensors detect no people or no movement in the room, it will switch off lighting or switch off air conditioning. The ventilation system and even the lighting system can be turned on. Okay, so this is the basic functions that EMS can offer in a building. Regarding the control of equipment by energy management system, the primary purpose of the control of equipment is to save energy by optimization of system controls. This is performed by the EMS function of the building automation system through scheduling and manual overriding. So you can set time of operation of various building services. For example, you can decide to set the air conditioning of a particular room in your building at certain time of the day and automatically switching it off. And then you can set control of set points. For example, you can decide for all the rooms in your building to have a temperature set at 24 degrees Celsius instead of occupant's own choice. And then the EMS can also report and record of any problems happening in your building, and it can be set to ensure correct and safe sequence of operation. This is necessary for a maximum demand limiting. Maximum demand limiting is you limit the power usage of your building so it does not exceed certain level, because in some buildings there is a penalty for the building if it incurs consumption beyond what is stated in agreement with utility companies. For example, if TNB set your building to operate at certain kilowatt in any time of the day, and if you exceed that, there is a penalty and you have to pay extra. So you can use EMS to prevent this from happening. Monitoring is an important part of having EMS. It's a very good, a very clear benefit. Then you have centralized information of equipment conditions and providing information of equipment conditions through basic trending. You can predict how equipments are being used throughout the year. Okay? Providing a management by exception function to alert the operator of any abnormal equipment conditions, and you can easily detect if any particular equipment in your building service is not functioning properly. Providing analytical tools to aid the study and management of equipment's operations and energy performance. So this is another benefit. When you want to do a retrofit, for example, you would want to know where the problem is, where energy is wasted, where it does not perform optimally. So when you have this data, then you can start to plan ahead, mitigate the problem. Okay, so this is another important, in fact it's a very important aspect of energy management system when you talk about energy efficiency. Then when you have EMS, you can monitor energy consumption in various areas. You can monitor the energy used, electrical energy used in air conditioning and mechanical ventilation system. Okay, typically it is the largest energy consumer in the building, and thus has the largest energy savings potential if you provide optimum air conditioning for your building without compromising the comfort of your occupants. The EMS shall place some special emphasis on the air conditioning mechanical ventilation as specified in 9.6 later on. In lighting system, the lighting system is typically the second largest energy consumer in the building and is recommended for inclusion in the EMS as specified in 9.7. If included in the EMS, the following should be considered. First, the capability and capacity of facilities management to maintain and operate EMS controlled lighting system. B, as lighting system in EMS is typically a massively switched array, its design and implementation needs to account for maintainability and flexibility for scaling up and changes. When you design a lighting in a building, you need to understand how your wiring and switching works. You cannot, you don't normally allow for each lighting to be controlled by a switch. You would have hundreds of switches in your buildings. So this is impossible. It is important for us to understand what is the best, the most optimized array of switching to achieve energy efficiency in a building. Okay, then there are other benefits, and you can control and monitor through EMS, such as water pump sets, heaters, and other things should be included under the EMS program. It is recommended that monitoring of renewable energy sources such as solar and wind energy systems be included to assist users to visualize energy balance and thence maximize the harvesting of such renewable energy sources. Okay. Um, this is a bit on the side of the psychology of the users. If perhaps you can have a visualization of how much electricity that you use, and then you would have the motivation to have control of how energy is being used. Okay, so if you can have this visualization of how many kilowatt hour the building is using, and you can start to think of what can I do, for example, when it is bright outside and you can switch off a few rows of artificial lighting to benefit from the day lighting, you would do that, and then you would immediately see the changes in the building energy use in the visual unit. Also, if you have renewable energy resources, you can immediately see, for example, if you install a set of photovoltaic solar PV on your roof, then you would see the reduction in the energy supply from the grid that your building is using, and this is almost like a psychological reward for those owners who invested in those photovoltaic panels in the first place. Okay. And also, water and energy are interrelated because, for example, when you are talking about mechanical cooling, you use a lot of water for your cooling towers to dissipate heat. So it is recommended that EMS to also monitor and capture data on water use efficiency. You must understand that treated water is also a source of carbon emission, because treated water requires a lot of energy. Use of this water actually implicate a lot of carbon emission. So not only by switching on electricity that your building will incur carbon emission, but also when you use water, potable water, treated water, you will also incur carbon emissions. So it is sensible for, once you have EMS, it is a matter of adding the proper sensors and communication system to report on water usage. Okay. It is typically not appropriate to apply the EMS to control equipment such as computers, which computers you might be able to control the power inlet or the power outlet of other equipment such as computers, printers, coffee machines, so on and so forth. But it is not advisable for EMS to control computers because it requires quite a different pattern of energy use. Okay, monitoring of equipment. Why do you want to monitor equipment? The purpose of monitoring the equipment is to improve the efficiency of operations by providing centralized information of current equipment conditions, providing information of equipment conditions through basic trending, providing a management by exception function to alert the operator of any abnormal equipment conditions, and providing analytical tools to aid the study and management of equipment operations and energy performance. The most basic function is you should be able to monitor. You might be required to fix a problem manually. For example, if you are alerted to a malfunctioning air conditioning unit in certain room in the building, you would be alerted, but you have to go there and manually fix it, the control through manual fixing. Okay, next part of the lecture we will look into the concept of building energy simulation. Building energy simulation, also called building energy modeling, BEM, or energy modeling in context, is a design tool to characterize energy flows connected to a building and predict their impact on comfort parameters and energy demands, energy use through mathematical models. A typical building energy model has inputs for local weather to decide whether your building needs heating or cooling and how much it needs them. Building geometry, you can decide on the form and the compactness of your building. Building envelope characteristics, that is the characteristic of your walls and roofs. Internal heat gains from lighting, people, and plug loads. Okay. Heating, ventilation, and cooling system. Operation schedules and control strategies. You can decide on how your building will be used, whether it will going to be operating 24 hours of the day, just like a hospital, or schools where you operate only a certain part of the day. And you can also simulate control strategies, how you want your building to behave with regard to all the environmental condition you require. A building energy simulation then uses mathematical models to represent building systems and their interactions in order to calculate thermal loads, system responses to those loads, and the resulting energy use, along with other metrics such as thermal comfort, energy use, carbon emissions, visual comfort, so on and so forth. Building energy models may be developed for both new or existing buildings. Major use categories of building energy simulation include architectural design, when you want to compare retrofit options. This is for existing building. Let's say you have an old building and the owner wants to reduce the energy use in the building, so you would have to do some changes to the building, retrofit. For example, putting in insulations, buying in new equipments, new lighting systems, putting in sensors, so on and so forth. So you can simulate the performance of the building by using the simulation software, and you can predict the performance by adjusting those parameters. So it is a lovely idea when you can create different scenarios of building performance to suit different budgets control. So this is a very valuable tool in the industry for you as a designer to provide options for your clients when you do retrofit for old building. And for new buildings, similarly, you can propose various options of whether your building want to be tall and slim, or compact, or going to be elongated east and west regarding the orientation, so on and so forth. So all these choices will have different energy outcome. So the beauty of this is that you can have various configurations, various scenario of your building architectural design, and you would be able to quantify the performance in terms of all the parameters mentioned earlier. And in heating and ventilation air conditioning design, you can calculate the thermal loads for sizing of mechanical equipment and help design and test system control strategies. So this is very important. Normally this is in the job of engineers. So what you would do is to provide your design, and the engineers will calculate the size of the air conditioning required, and the number of lighting, the power of equipments regarding the building environmental service. So with this simulation software, you can at the design stage start to modify and put on different scenarios and operating condition without having to complete your architectural design at certain detail before you have to pass them to the engineers. So it is a very helpful facility for you to be able to use. Okay. And building performance rating to demonstrate performance-based compliance with energy codes, green certification, and financial incentives. Remember the GBI marking system. So how do you quantify and establish the energy use of your building, whether it achieve the targets of 90 kilowatt hour per meter square per year or not. So this is the use of building simulation. Okay. Building stock analysis, it supports development of energy codes and standards and plan large-scale energy efficiency programs. When you have such enough data of various building performance, you can do benchmarking. You can establish the standards, the normal standards of the current market scenario, and you could put this into your energy requirement in your rating tool or documents such as MS1525. You can start to stipulate that this X is the BEI required for all buildings to achieve before they will be approved for development, for example. Okay, so once you have this, these are all possible when you have building simulation. Okay. So what do we simulate? And in building energy simulation, we can simulate heating, we can simulate cooling, we can simulate energy use for lighting, we can simulate energy use needed for ventilation, and we can simulate various other parameters of the buildings. Even these days, you can simulate how people exit through a building, which is very important, as you have heard recently in the news, how people got trampled to death because of bad exit strategy in emergency in a building. So these can all be simulated in a simulation program. Okay. So the type of simulation analysis that can be done in an average building simulation package in the market now, there are various types of analysis. For example, you can do shading analysis. You can put in various shading design on your window. We are talking about external shading, yeah, because shading has the potential of mitigating heat transfer into your building by blocking direct sun radiation through your glazings. Or even if you put shading on your opaque walls, it helps reduce energy absorbed in the walls, which later on will be transmitted into the building. Okay. You can do daylighting analysis. You can quantify what is the level of lighting in your building. Should you put your window of certain size? What happens if you put the shape of your windows this way, or how you distribute your openings? You can use this simulation package to do daylighting analysis. Ventilation analysis is another important aspect of simulation, but normally you require special engine. Engine is the algorithm or the calculation being used by simulation program. Ventilation is requires quite heavy calculation, because you need to understand how air moved through your buildings, if you provide openings or if you provide mechanical ventilation from your outlets, how the air travel throughout your building or throughout your room. This will be very, very important for you, and it relates to thermal comfort analysis, because air movement around occupants help to affect thermal comfort experience of occupants. Okay, so in thermal comfort analysis, you will use the parameters provided in the simulation analysis. For example, temperature, radiant temperature, humidity, air movement, and this will be calculated to provide derivative indices such as thermal comfort indices to give an idea of how comfortable your building is thermally. Okay. Escape route analysis, I have mentioned earlier. In emergency situation, you would help it will help you to understand how would you locate your exit. and what is the size of the openings or the path needed. So it can be done by simulation these days. Energy analysis, of course, now using the thermal comfort analysis, the building will then provide the situation or the condition to which how much energy needed to provide those level of comfort that you state in your simulation. And from this demand, you can the simulation program can produce exactly how much energy is needed to provide that kind of air conditioning. Similarly, in daylighting, if you provide enough good daylight harvesting in your building, then the simulation software will compensate, will take the daylight harvesting as a discount against the actual energy needed for providing daylighting in your building. Okay, so the resulting energy intensity is the values or the quantity that you would use to report the performance of your building in GBI in MS 525. So you can see how important it is for you to understand or to be able to use building energy simulation. This is an example of one of the software, the package that would allow you to do simulation on buildings, called IES. It's a very good simulation program, even though a bit pricey. Okay, you can read the detail of this this package, and it is well-established software, simulation software in the market, and it is accepted for use in internationally recognized building rating systems such as the energy standards or European energy standards and LEED rating system. Okay. Okay, there are various other software simulation programs such as Ecotech, Energy Plus, all those names there, and also Design Builder. Design Builder is the one you are learning right now and is available in our physics lab. You should be able to do some comparative analysis of the pros and cons, the benefits and disadvantages of various simulation programs. They are not the same. Some excel in, for example, in ventilation analysis. Some is better in lighting analysis, shading analysis, so on and so forth. But I think in the market now you can compare, they do a good comparison of which software is the best for your purpose to suit your budget, so on and so forth. Of course, the more accurate, the more versatile the package, it will be more expensive. Okay, you can download, for example, I don't know whether it is still free, but previously Autodesk provide Ecotech analysis. If you have done your building in AutoCAD, then you can use the online service to do this analysis. Okay, please have a look. I don't know, this was some time ago. I don't know what is the terms and condition now. Okay, so among all those building performance simulations, there need to be a standard to regulate the simulation software, because the implication of the use of this software is huge. For example, the rating of your building, it will help policymakers to decide on certain strategies and steps and measures to improve energy efficiency. So you need some sort of validation of how good the software simulation software is. So that's why there is an International Building Performance Simulation Association called IBPSA. It is a non-profit international society of building performance simulation for researchers, developers, practitioners dedicated to improving the built environment. It aims to provide a forum for researchers, developers, and practitioners to review building model developments encourage the use of software programs, address standardization, accelerate integration and technology transfer via exchange of knowledge and organization of international conferences. So they are trying to have a standard through this association to control and regulate the use of this simulation software. Otherwise, anybody with some computer skill can claim to produce an apps that provide accurate building simulation, whereas the accuracy is questionable. Okay. It also aims to support the users of this software. It has partnered with ASHRAE. ASHRAE is the association that regulates the heating, refrigeration, and ventilation services in the US. And IESNA is another organization that controls the lighting performance of building. Okay, so with this, the help of these organizations, they are developing energy modeling professional certification scheme. Okay, if you are interested to have this certification, it will be a great addition to your resume. If you can do, then you would be able to offer a professional service in building simulation. Okay, you can look them up. I believe now they have more to offer than when this was presented earlier. Now, to understand how simulation is used in MS-1525, we have to revisit what MS-1525 is all about. It's a document stating the performance and specification of energy efficiency in office buildings. So in the documents, if you remember, we talked about passive design strategy, building envelope, lighting, so on and so forth. Basically, this document is a specification of what energy standards should be achieved by buildings in office buildings in Malaysia, and it applies to buildings of more than 4,000 square meters in size. Simulation is used in a way that need to be explained here. First, this document mainly use prescriptive specification so that the buildings meet energy standard. For example, in building envelope, if you remember, MS-1525 talked about achieving maximum OTTV, overall thermal transfer value of the envelope, of not more than 50 square meter, 50 watt per square meter. And in terms of lighting, the lighting power, the electric power, and the distribution. So even in air conditioning and mechanical ventilation system, there are specifications of energy efficiency for equipments used in this in the air conditioning system. Okay, so there is another way of meeting or achieving the compliance instead of sticking to the prescriptive specification stated earlier. That is stated in clause 10. You can do this by building energy simulation. That's why it is called an alternative compliance method. So the scope of building energy simulation method is not prescriptive. It is performance based. That means it does not care what specifications of building components or building system components you use, as long as the eventual annual energy use is the same. So you might want to explore your building using different methods of achieving energy efficiency. To do this, you must prove this by doing a simulation. Okay. So how do you go about doing the simulation? You must do two types of simulation. I mean, two times simulation. The first simulation should be for our building as per design. That is the building that you wish to construct. the actual design that you propose. So it is called the design building. Another second simulation is for a reference building. The building must be similar in certain characteristics to your design intention, but it is a simple shoebox building, and this shoebox building must meet all the prescriptive requirements. So it is not exactly the building you design, but it resembles in terms of volumes and spaces and the number of floors that you design, and all the prescriptive specification should be met in this base building. It is called base building. Okay, but so the base building must meet all the clauses I mentioned earlier, 5, 6, 7 and 8, the air conditioning system, the OTTV, the lighting and electrical power system must meet that requirement for the base buildings. The design building shall be modeled accurately from the architectural design drawings available, that is your design, but the base building shall be modeled as the model assumed for deriving the OTTV. Shoebox building, you must model it as a shoebox building with these characteristics. The base building shall have the same floor area as the design building, and same number of floors as the design building, and same function as the design building. So let's say you are designing a hospital, so the base building also should perform the function of a hospital. And the base building should comply the minimum requirements for OTTV, RTTV, lighting, and all those components and equipment stated under clause 5, 6, 7, and 8 earlier. So the hypothetical, the base building, the shoebox building must meet the prescriptive requirement of the document. Okay. So when you're designing the base building shall be as functional as the design building. The base building, remember, the shoebox building, that means it's a plain rectangular building, and shall share all the same characteristic of the design building with the exception of the following. Of course, the building form will change. Now it is a shoebox, and the building envelope is also different because now it has to meet the requirements specified in clause number 5, and all the daylighting and lighting control and the air conditioning and mechanical ventilation system would have to meet the prescriptive requirement. So what this does is that it allows the designers to compensate for a poor building envelope. Now your design building envelope does not meet the OTTV requirement, for example, because you want to have more daylight, you have a larger window which increase the OTTV, but then you would like to introduce daylighting control system which mitigate the energy requirement for daylight, or you would propose that in your design building you would use more energy efficient chiller, for example, with higher COP. That would eventually make the energy use, the energy demand of your design building comparable or matches that of the base building. Okay, so the clause also specified the simulation programs. The simulation program should be a computer-based program for the analysis of energy consumption in buildings. The simulation program should include calculation methodologies for the building component being modeled and incorporate the following. Right? First, the simulation program should be able to do minimum of 8,760 hours times that per year. That means the simulation will calculate hour by hour, and that is the minimum hour that the simulation program should be able to do, okay, per year. A minimum of hourly variation in occupancy, lighting power, miscellaneous equipment power, thermostat set points, and ACMV system operation defined separately for each day of the weeks and holidays. That means in your software, it should allow you to set different operation time for different day of the week, and sometimes you can also reflect when the building is not used. For example, a school building or a university campus. There are certain time of the years it is empty because of holidays and there are no students in campus. So you should be able to simulate that. Okay. And the software should also be able to reflect thermal mass effects. Thermal mass effects is the ability of the building envelope to retain heat and re-release the heat later. This is especially true in, especially important in our climate, where during the day, heavy mass construction, it will absorb the heat from the sun during the day, but it will release the heat slowly during the night. So the software should be able to reflect that effect. Okay, so if the software could not do that, it is not does not meet the requirement of the alternative compliance in AMS 525. Okay, and the software should allow the designer to divide the building into thermal zones. For example, if you have 10 rooms which you control the air conditioning differently, or some are not air conditioned, so on and so forth. So the software must be able to reflect that. You don't want to have the software only to simulate the building as one big mass or big volume. Okay. For that, there are many software and freewares available, but you have to check the latest ruling on that. Okay. And also, the simulation program should have a report. The report must be standard, such as ASHRAE standard 140, various mechanical air conditioning report that can be compared with, can be produced as a standard report. So most of the capable software, they have this internally built. That means you can produce such reports. Okay. One important thing is climatic data. So when you have your buildings and you want to design, say, a building in Kuala Lumpur, then the climatic data you use, you must choose the climate and the weather data from Kuala Lumpur. Okay, and you must the data should have the information of a test reference year weather data that consists of at least hourly values of climatic data. So the data is the climatic data should represent a typical year, right? We call test reference year, and the climatic data should have the information of hourly values. That means for every hour, the temperature, the humidity, the wind speed, so on and so forth, that should be included in the weather data. So most of all of the software programs, the building simulation program, will allow you to choose weather data of your choice. So it is important for you to find the reliable weather data. So it is not acceptable, for example, if you design a building in Kuala Lumpur, but to do the simulation you use weather data of Bangkok, or even Seoul. So it will not reflect the actual performance of the building in the climate. Okay. For cities or urban regions with several climatic data entries, and for locations where weather data are not available, the designer shall select weather data that best represent the climate at the construction site, but shall not be more than 200-300 km away of the design location and be of similar altitude and land or cityscape. That means, for example, if you are designing a building in Bentong, Pahang, okay, and you could not find the weather data for Bentong, but the Met Office in Kuala Lumpur has the weather data, and you can use that as long as it is since Bentong is not 300 km away from the weather data of Kuala Lumpur, then you can use the data from Kuala Lumpur. So weather data is something that you should choose carefully, right? Now, should your simulation shows that your design building does not meet the requirement in MS 1525, that means your design building consume more energy than your base building, then what are the options? There is another option that you can resort to. One is by using renewable energy, and this is stated in clause 10.7 under the title of exceptional compliance. What it says there is utilization of on-site renewable energy sources such as photovoltaic or site recovered energy is encouraged. The annual energy consumption of the design building is permitted to be reduced by subtracting 100% of the annual renewable energy or site recovered energy utilized. Simply put, that if you have a renewable energy generation on site, then whatever building energy intensity demanded by your building can be reduced by subtracting the amount of energy produced by your renewable resources. Let me give you an example. Let's say your building, your design building, the energy consumption of the design building exceeds that of the base building by 20 kilowatt hour square meter per year, right? So now, if you can generate, say, this 20 kilowatt hour per square meter per year by renewable energy using photovoltaics or wind turbine, then you can subtract 120 from 120, you get that 100 kilowatt hour per square meter per year, and that match the performance of the base building, so you are okay. So that's what it does, is to encourage the use of renewable energy on site. Now, if let's say your design building requires 120 kilowatt hour per square meter per year, and the amount of energy you generated on site from renewable resources is more than that, that means your building does not import any electricity from the grid. You use renewable energy, then you don't have to even do the simulation. You don't have to do that. So that's the benefit of having renewable energy on site. Because why would you need to do that, since you are not producing any carbon emission? You are not using any electricity from the grid, so you don't have to do the simulation. But as of now, on average, if you are to provide renewable energy on site, the cost is way too high, way too much for the building economics to have feasibility of doing that. Okay, so when you done the simulation, what you should do is you will achieve compliance with two conditions. First, the design building annual energy use does not exceed the base building annual energy use as calculated by the same simulation program. That means, for example, if your shoebox hypothetical building, let's say, produce building energy intensity of 100 kilowatt hour per meter square per year, then the your actual building, the BEI of your actual building shall not be more than 100 kilowatt hour per meter square per year. Okay, so that is the requirement, the first condition, so that it shows that your building, whichever way you choose the specification might not meet the minimum requirement of OTTV, so on and so forth, but you can show, if you can show that your parameters, your design building can achieve similar building energy use, then it's okay, right? Another requirement is that the energy performance rating for equipment for components specified in the design building are not less than the rating used to calculate the base building energy consumption. That means another condition is that the equipment is, for example, the energy level of your air conditioning, of your chillers, the machine, the engine that produce cool air or water. There are energy levels. Okay, for example, you have 3-star, 4-star, or 5-star rating. Okay, you cannot use something that is less energy efficient than the one you use in your shoebox in your hypothetical burning simulation. So if you meet these two requirements, then you have shown compliance. That means in MS1525 definition, your building has achieved the required standards for energy use. Now, should your simulation shows that your design building does not meet the requirement in MS1525, that means your design building consume more energy than your base building. There is another option that you can resort to. One is by using renewable energy, and this is stated in clause 10.7 under the title of exceptional compliance. What it says there is utilization of on-site renewable energy sources such as photovoltaic or site recovered energy is encouraged. The annual energy consumption of the design building is permitted to be reduced by subtracting 100% of the annual renewable energy or site recovered energy utilized. Let me give you an example. Let's say the energy consumption of the design building exceeds that of the base building by 20 kilowatt hour square meter per year, right? So now if you can generate, say, this 20 kilowatt hour per square meter per year by renewable energy using photovoltaics or wind turbine, then you can subtract 120 from 120, you get that 100 kilowatt hour per square meter per year, and that match the performance of the base building, so you are okay. So that's what it does, is to encourage the use of renewable energy on site. Now if, let's say, your design building requires 120 kilowatt hour per square meter per year, and the amount of energy you generated on site from renewable resources is more than that, that means your building does not import any electricity from the grid, you use renewable energy, then you don't have to even do the simulation. You don't have to do that. So that's the benefit of having renewable energy on site. Because why would you need to do that, since you are not producing any carbon emission, you are not using any electricity from the grid, so you don't have to do the simulation. But as of now, on average, if you are to provide renewable energy on site, the cost is way too high, way too much for the building economics to have feasibility of doing that. Okay. So in GBI, the use of simulation is mentioned in EE5. EE5 is the criteria talking about advanced energy efficiency performance. It can garner 15 points if you do well in this section. So in EE5, the idea is for you to employ all good energy efficient design strategies, including passive design, active design, using energy efficiency component for your buildings. Then how do you show the building is performed correctly? Then you have to use building simulation. So the building simulation is used to produce BEI. Okay, we have to revisit the definition of BEI. I believe I have explained this in earlier lecture. BEI is building energy intensity, and the unit is kilowatt hour per square meter per year. So
sort of give you the apple-to-apple comparison between buildings when you want to compare their energy use.
Okay, in GBI, in Green Building Index, the BEI is an important part of the scoring when you apply the GBI rating tool. It is stated in EE5. You should try to achieve the lowest BEI possible for your buildings, and the minimum BEI you should target for your building to get the lowest point, that is 2 points, is it should be less than 150 kilowatt hour per meter per year. And if you reduce more and more, you get more and more points, up to a maximum of 15 points. That is, if you can achieve 90 kilowatt hour per meter square per year. But you have to check with the latest publication of GBI. They might have changed the maximum BEI, because nowadays buildings are generally getting more and more energy efficient. As of now, if you manage to reduce your BEI to less than 90 kilowatt hour per meter square per year, you would get 15 points out of 100 points in GBI scoring. Now, to give a clearer understanding of what have been discussed, I would like to conclude with a comparison of the use of simulation between what is required in MS1525 against how it is being used in GBI. So in GBI, you use simulation to provide BEI values to give score. In MS1525, the use of simulation is to compare the energy compliance, that is the energy used by your design building, and compare it with the base building. So if your design building, the energy use of your design building matches that of the base building is the one that use the specification as stated as required in MS1525. If they match, then you are okay to go. Otherwise, if your design building use more energy than the base building, then you have options of mitigating the energy use by using daylighting, by using better equipment than the minimum requirement, that you have to spend a bit more on your design building to achieve similar energy use. And lastly, I had explained that even though if your design building uses more energy than your base building, then you have the options of reducing the values by subtracting the energy use generated from the renewable resources on site. So that is to conclude the lecture for today. Thank you for your attention.